From last time, please. So remember we were talking about midpoint stuff. Talked a little bit about Pythagorean Theorem, midpoint stuff. How to attack a problem when you have the midpoint and an endpoint, how you work backwards a little bit from it. Started doing some simple radical forms, so finding the biggest square root. And then we started talking about right triangles, and there's certain right triangles that they call them Pythagorean triples, which come out to nice whole numbers. So this is one of them. So you have 3, 4, 5 right triangle. This is one that you will see often, and that's what we have for you on that. So Pythagorean theorem, I believe, depending upon which school you're in. Oh, you can always just run past it. You're fine. Pythagorean theorem, I believe you have seen Pythagorean theorem since about 4th or 5th grade. So it's kind of been out there for a while. It's been around since the 6th century BC or BCE, depending upon which thing. I think they mean the same thing. Well, one's before Common Era, one's before Christ. So depending upon where you go with it. Thanks. She was on. Sorry, she was on. All right, so let's take a look. How can we use the idea for the distance between points? So how we're going to utilize the Pythagorean theorem is we have to realize we have a distance right here. And the distance right here. I don't know why I did the little EKG jump on me, but okay, that forms a right angle. Does everyone agree? Yeah. We have a right, left. We have an up, down. So without necessarily even using our points, we have to realize the distance from here to here. So from 1 to 9, we got just count. You got 1, 2, 3, 4, 5, 6, 7, 8. So that distance is 8, and then going up from here, I got 1, 2, 3, 4, 5, 6. And if you use the Pythagorean theorem, you'd find that 6 squared plus 8 squared is equal to segment AB, quantity squared. Make sense? So I get 36 plus 64 is equal to segment AB squared. So that's 100 is equal to segment AB squared. And if you remember your algebra 1, you have to take the square root of both sides. So segment AB is going to be a distance of plus or minus 10, but we're talking about a distance, so it has to be the positive component. So the distance right here is 10 units. Okay, so Pythagorean theorem works pretty well with this when you're able to count. Okay, will it work every time? Absolutely. But there might be a shorter distance. Okay, what are the coordinates of C? Well, the coordinates of C looks like 9, 1, I think. I don't know why they're asking that question. But how can we trust the idea about the distance points according to height? Yeah, so that's everything about how the Pythagorean theorem would work with the distance formula. So the distance formula was derived from the distance formula was derived from the Pythagorean theorem, and that's exactly how we would do it. So that's how we'd find the distance. Yeah.
Okay, so would we ever use the Pythagorean theorem to find the midpoint?
Probably not. The midpoint really is going to be the average of the x and the average of the y, and then going with that way. All right. So the general idea. So what are the lengths of the two highlighted sides? So they have to be some sort of positive length. Would you agree? Because you're talking about a length. Okay. How do we know they will always be positive when we use Pythagorean theorem? What has taken place to a length with the Pythagorean theorem? What's the main factor of it? Yeah.
Well, that it's squared.
That it's squared. So we have a quantity squared. So the quantity squared will always make it be a positive number. Okay? So generalizing the idea, if you have a right triangle, bless you, you have a side here and a side here. If you square those, sum them together, and then take the square root of it, you'll get the hypotenuse squared. Okay? The hypotenuse is the longer of the legs. It is directly opposite from the right angle, which is the 90-degree angle. Okay? Can this triangle happen in any one of the 4 quadrants? The answer is yes. And in order to continue to say that we have positive lengths, if you square anything, even though it's negative, it will turn into positive. Okay, so the distance formula. We got the hide and seek thing going. Okay, so if point A is x1 and y1 and point B is x2 and y2, how do you know which one's point A and which one's point B? Either labeled, you label it, you have to decipher it in some way. So on the coordinate plane, the distance between A and B is AB is equal to, that's the distance formula, okay? So think about this. If we work this a little bit backwards, you could get, and this should be segment AB. We're getting sloppy. If I started doing this, what did I just do to both sides to get rid of the radical? I squared both sides. So then we have the change in A, or the change in our x value squared, and the change in our y value squared. So this is where Pythagorean theorem starts linking up. Okay? The hypotenuse squared is equal to the length squared plus the length squared, or the leg squared and the leg squared. Okay, so distance formula is a go-to for us. Can I clear? Yeah.
Wait, so why is AB squared on the other one?
Why is this one squared?
Yeah.
All I did is I just squared both sides, and I got rid of the radicals. So this then says, of our triangle, where this is A to B, this segment here squared is equal to this plus this quantity squared. So that's kind of where the Pythagorean theorem goes with it. Okay, you can reason most of the formula by deciding how far apart the x-coordinates are and how far the y-coordinates are. And then you would square those values, add the squares together, and then take the square root of that sum. So in math, a lot of times you get happy going, dude, I have a square root key on my calculator, and you go to the square root of 8, and you find the square root of 8 is 2.4 repeating decimal forever, which your decimal only takes it out 9 spots. So you're like, oh, that must be an exact answer. No, it isn't. It's a decimal approximation. The iteration process on your calculator has to allow it to truncate someplace, or it would go forever, or until the batteries ran out. So an exact answer is leaving something as a radical. Taking it out, if you had square root of 18, you could break that down to square root of 9, square root of 2, which is 3 root 2. 3 root 2 is an exact answer. Exact answers are really good. You want your computer programs to recognize exact answers, because in the science world, exact answers are great. Unfortunately, you have margins of error that take place in science. Significant figures is what always kills kids in science. Because, well, my calculator goes out this far. Yeah, but you measured it with a triple beam balance, so you had 3 different iterations. You can only go out 3 decimal places because of your triple beam balance. Yeah, but the calculator, I don't care what the calculator says to you. The triple beam balance takes it out to the thousandths of a gram, or a thousandth of an ounce, depending upon what your weight measure is. Okay, so why do you use significant figures in science? Because your calibration and your measuring devices only go out so far, even though your calculator will go much further. Okay? So be cautious in chemistry or in physics when they're wanting exact answers, and you think the exact answer, you think you're smart because you're putting down an answer that's this long, that's all the decimals on your calculator going, this is even closer than that. No, leave it as a radical if you can. So find the distance between the pairs of points. I think it's important to label x1, y1, x2, y2. I could have had this x2, y2 and this x1, y1. It's still going to work out. Our distance formula is the change in the x value squared plus the change in the y value squared, which again, we've discovered that this relates back to our Pythagorean theorem. Okay, so this is going to find us the distance between these 2 points. So let's plug in our values. So I have the square root of x2 I have as -1, x1 I have as -4, quantity squared, plus y2 I have as 2. y1 I have as 10. I'm going to square that. So this is negative 5. What is negative 5 squared? 25. Plus 2 minus 10 is negative 8. Negative 8 squared is 64. And if I add 25 and 64 together, I realize it's root 89. That's as far as you can go. That's an exact answer. How far is it root 89? How big is root 89? Well, root 81 is about 9. Root 100 is 10. So the answer is between 9 and 10. Okay? Where exactly is it? Root 89. How far is it? Root 89. That's an exact answer. I understand, again, that your calculator takes it out many places. And that's fantastic. But your calculator doesn't give the exact answer. Okay? We can work this problem. Just for the heck of it, I'll label this way. What did I do? I just flip-flopped the way I had done it. The answer is going to be the exact same. So you have the square root of x2. So we have 3 minus 9, quantity squared, plus 3 minus 9, and negative 6 minus negative 8, which is that. Did I do that math right? So 3 minus 9, negative 6 minus negative 8 is negative 6 plus 8, correct? 3 minus 9 is negative 6 squared. Negative 6 squared? 36. So under the radical, I have 36 plus negative 6 plus 8 is 2. 2 squared is 4. This comes out to square root of 40. Can I break root 40 down into some perfect squares? What's the biggest perfect square that goes into 40? 4. So 4 times 10 is the same thing as 40. For those of you saying, well, what about 8 and 5? You're absolutely right. Those are factors of it. But we want one of the factors to be the largest perfect square. The largest perfect square will be 4. So what's the square root of 4? 2. So this answer comes out to 2 square root 5. It's a nice exact answer.
Wait, why is it 5?
Oh, it should be 10 because I'm not paying attention. Yeah, of course, I've made it a big mess now. That's 2 square root 10. How we doing? Feeling all right? Make a water drop noise if you know how. You guys get it? Sorry. How do you do that? All right. So we now have enough information to complete worksheet 1.7. Okay? I'm going to move this to Thursday. And I know most of you are going to cry yourselves to sleep tonight, but here's the problem, okay? Here's the problem. We're going to work on 1.7, get this done. 1.6 you've already handed in to me. 1.7 you're going to work on for the rest of the period. Tomorrow we're actually going to start on 2.1. I will go over 1.7 tomorrow with us during class, and then we start the next unit, and then Thursday we will take the test on chapter 1. And what? See, I struck through Wednesday.
I thought, never mind.
So Thursday is test day. I'll change it over here so people feel better about it. I'll straight through test. I know I have such great notes over here. So we will do 2.1, start on that tomorrow. And I know most of you are going to cry yourselves to sleep knowing this, but we didn't have a Schoology section for the test. Sorry. I know you're bummed. You know, kids are going to go out and kick their puppy now. Wasn't a real puppy, you guys? No puppy. Okay, you guys know it, and girls know what to work on between now and the end of the period? You feel all right about it? What's that? Well, I'll teach you tomorrow, so it'll technically be Friday, I guess. But this is everyone's favorite. Some of you probably walk out of class because you start talking about supplementary again. So looking at this worksheet 1.8, let's utilize this as some notes. Okay. The larger of two supplementary angles exceeds 3 times the smaller by 4. Woo-hoo-hoo, man. How do we do it? Supplementary angles, what do we know?
180.
Yeah, so the larger of two supplementary angles exceeds 3 times the larger of two supplementary angles. So basically I have something like this. Okay, forms a linear pair. So I have the larger of two. So we'll call this one the larger. Sounds good? So the larger of two supplementary angles is 3 times the smaller by 4. 3 times the smaller by 4. Oh my gosh. So, ideas? What does 3 times the smaller by 4 mean? Oh, exceeds. Okay, so exceeds 3 times the smaller. So if this is the smaller, then this one is going to be 3. Did I do it right? The larger of two supplementary angles, so the larger, that's the larger one, exceeds 3 times the smaller by 4. Holy crow. How do we solve it then once we get that? And how did I know this one was 180 minus x and that one's x? Yeah.
Well, 180 minus x is the supplementary
Right.
formula.
There you go. So what should I do with these two in order to solve x and then figure out what the angles are? Yeah. Because I knew you'd be mad at me if I gave you one. Did you?
Oh, yeah, right.
And do you have 2 of them there?
Yeah. Sorry about that.
Finally not my fault. Finally not my fault. How do we solve this now? Yeah.
Do them equal to each other?
But they're not equal to each other. But they are equal to something. What are they equal to? Go. Yeah. So I have this plus x equals 180. Yeah? I don't know what this is. That just showed up. So 3 times 180 is 540. Minus 3x plus 4 plus x equals 180. I found that because I used to skateboard as a kid, that I'm able to do like 3 times 180 really easy because I know it's
I
540.
was actually just thinking about
Dude,
that.
man, we're on the same page. All right. All right. So let's work this out. X, that's gonna be 544 minus 2x is equal to 180. How do I solve that now? Or is anyone stuck on that? So what is 180 minus 544? Negative what? Negative 364, I'll take that. And divide that by negative 2, we get 182. Positive. Okay. So that's what x is. So that's 182. Anyone got a problem yet? Big one? And then the other one is 180 minus 182 is negative 2. 3 times negative 2 is? 3 times negative 2 is? Negative 6. Negative 6 plus 4 is? Anybody got a problem with this? Okay, negative angle I am okay with.
This angle should not be. How do you have a negative? That's an obtuse angle.
Algebraically, I had to do it that way to make it work. 182 degree angle. What's my problem? Supplementary are what? 180. What can we say about this problem? Yeah, it's not a solution to it. This is a scenario that can't happen. Algebraically, we can make it happen, but geometrically, we can't say, hey, these two angles are supplementary, and one of them happens to be 182 degrees. Okay? But I guess if we wanted to get goofy on this, we could go a little bit further and talk about, okay, if I were to start here and go 182 degrees, I'd get to here. Is that all right? And then, having this be a 2-degree angle, if I were to go the blue minus the green, I would get 180 degrees. So, is it real? Can we do that? I don't know. I mean, it might be something we could start exploring a little bit later. Or did we do this wrong?
Maybe.
Yeah.
Did you do like the other way that's like x plus parentheses 3x plus 4 parentheses equal to 180?
Maybe. This seems to logically make sense that they equal 180, but let's read the problem. The larger of two supplementary angles exceeds 3 times the smaller by 4.
It's a smaller one.
Also, it's
Because you wrote it with the big one.
Okay,
Yes, maybe?
maybe.
Yeah.
What's that? What is the angle equal to? No, what is the angle equal to? What does the problem say?
Well, yeah, 3 times.
I don't know how to do this in words.
Should it be equal to 180 degrees?
Yes.
Supplementary angles are, do you agree? But do we know we have a relationship between the angles?
Yes, because they're supplementary.
They are supplementary. But it says we have this angle with this relationship to it. So if I take that angle and do something to it, I'm going to get that angle. Hang on. Let's do this. All the work that we did is down here someplace. Let's try this. Why? Yeah, it's the relationship between them. So we still have our 540, thank goodness we know how to skateboard, equals this.
Negative 2x equals 544.
So what?
Negative 2x equals 544.
No, not negative 2x. We're going to have to do this.
Oh, 4x.
Add it. 4x equals 544. So x is equal to what?
136.
What?
136.
You sure? 136?
What?
That seem like a nicer angle?
No, it's still more than 130. No, wait, just kidding.
So if we have one angle this, and then we know they're supplementary, what does the other angle have to be? 180 minus that, which is how much? 44? So I have an angle of 136 and an angle of 44. Does that seem logically like it should be, rather than having a 182 degree angle? So there was 2 different ways that we could have approached this problem, but one of them got us something that's not a solution because, one way to approach it is I have an angle plus this equals 180, but then I have the relationship between I have this angle, but I know that the other angle is this or triple or whatever it said, the supplement of it. That's a tougher question, yeah.
Okay, so why couldn't you have just done 3x plus 4 plus x equals 180?
3, what?
Like, because the smaller one is
3x
x.
plus 4 equals what?
Or plus x equals 180. Because, like, the smaller one is x. And it's
Equals
3
180?
times.
Is that what you said?
Yeah.
No, wait. Oh yeah. That's what I did. I got 44.
Do you get the same answer?
Yeah, I got 44.
Huh. Tougher stuff. All right. Let's just do 6 and 7 real quick and we'll get out of here. Yeah. Well, I just wanted to explore it a little bit. I don't know if you'll see it this tough on the test. I mean, this is tougher. Number 6. 1/2 x minus 8 equals 3/4 x plus 2. What's the quality way of doing these problems? Multiply everything by what? Not by 2. By 4. So that's by 4 over 1. That's by 4. That's by 4 over 1. That's by 4. That gives me 2x minus 32 equals 3x plus 8. Solve that. What about number 7? What should I multiply everything by? Multiply everything by 12. Good. Why 12? Someone's sitting there going, could I use 24? Yeah. So multiply that by 12 over 1. This by 12. This by 12 over 1. This by 12. Okay? This goes into that. That becomes 4x minus 24. That goes into there. That becomes 3x plus 60. And then solve that. It's like x equals 84. Okay? I want to go through 2, 3, 4, 5 tomorrow as some notes, some review, and then we're starting on 2.1. And then we have the test on Thursday we move to, correct? Everyone happy?
Is 1.1